screen?
Oh, yeah.
Okay, perfect. Let's
Yeah.
see.
So,
Is my full screen visible for you?
yeah, it's all good.
Perfect. Yeah, so let me
Uh,
just like,
so, yeah. So before we start, can everyone turn on the camera so we can have a picture before we start? Sorry, Professor Annie, you muted yourself.
Oh, okay.
Oh.
Oh. That's where are you guys?
At the residences.
Where, sorry, where?
At one of the residences.
Oh, okay. Why isn't Santiago here? He could like go to BC and visit Dr. Al-Maki. Okay, go. Nasser, do you want to turn on your camera? Let's get started.
yeah,
Okay.
should I go?
Sorry. Wait a second. Okay. Yeah. So thank you so much for everyone. And yeah, thank you so much, Dr. Abdallah. And for it is also my pleasure to introduce our speaker, Dr. Abdallah. And he is a postdoctoral researcher at the University of British Columbia, specializing in multilingual and multicultural natural language processing. His research focuses on developing inclusive large language models for low resource and underrepresented languages and cultures, with particularly uh, expertise in Arabic dialects, cross-lingual learning, and culturally aware AI. He holds his PhD in computer science from Muhammad VI Polytech University in Morocco and previously conducted postdoctoral research at MBZUAI. And his work has been published at leading MLP venues, including ACL, EMMLP, and the NACO, and has received multiple awards at ACL affiliated references conferences. Yeah, so today Dr. Abdallah will be presenting Now Chat, building LLM that speak the language and understand the culture. Um, um, we are happy to have him with us today, and yeah, let's get started.
Thank you, Chifan, for the very nice introduction, and thank you for having me today. So, I'm Abdellah. I'm a postdoctoral researcher at the University of British Columbia, and today I'm going to present a recent work that we have been doing here at UBC that is about how we can build a large language model that is both linguistically and culturally aware, and that this LLM basically can serve a specific community in the world. The name of this project was Nightshade. That's like the name. So before starting, I'm just like going to give a brief just like introduction about my background. I guess like Chifan already like mentioned most of the things here, but I'm just like going to highlight some things. So basically we are working here on multilingual and multicultural AI for especially like the Arabic and the African languages. So when I say the Arabic languages, we mean like the Arabic dialects, because like the Arabic language have like the standard language, and then it have like a long variety or like a large variety of dialects. Like let's say there is the Moroccan dialect, there is the Egyptian dialect, there is the Saudi dialect, and so on. And each of these dialects like differ across them. And then on the other level, there is like the culture, like the Moroccan culture is different from the Egyptian culture, it's different from the Saudi culture, and so on. So the research that we are trying to do here is basically how we can build evaluation tools, how we can build large language models, how we can do machine translation in a way that it would respect these dimensions of the language and the culture at the same time. So before coming here to UBC, I was doing like a postdoctoral research at MBZUI in UAE, was where I was working on the same topic, multicultural and multilingual LLMs. And my PhD was in Morocco in the Mohammed VI Polytechnic University, where I was working on building NLP systems for underrepresented languages, like mostly Arabic dialects, where we were focusing on using like dominant adaptation transfer learning methods, like in order to make the existing NLP systems like more accessible for other languages. So the outline of this presentation will go mostly around like multilingual LLMs. We will see why LLMs, basically not why, but like just like the rationale of LLMs like underperforming in some low resources languages. We will talk about like the trade-off between the culture and the language when it comes to LLMs, and then I will present our work, multilingual and multicultural, how to build like multilingual and multicultural LLM for a specific low-resourced community. So in this map that you see in this slide, basically you have like access to all the languages in the world. Till now, there is like around 7,000 languages. And if we just like take a very quick example here of these languages, we would see like this language called Terifit language. It's a language from the city where I grew up in Morocco. And it's a language that is being spoken by around like 5 million people in the world. Like these people like are basically just like are from Morocco, but like they are distributed around the world. And the thing is that this language is mostly like a spoken language. We use it like to write maybe over WhatsApp and so on, but like we don't use it like for formal documents. So if we just like go to one of the very frontier LLMs, now let's say like ChatGPT 5.5, and then we ask it to translate a very easy English sentence from English to Terifit language, then we will get like this two plausible translations that the LLM basically think that they are correct. But as a native speaker, I can tell you that these two translations are very wrong. And they don't represent the language, and most of the terms that we have here are very inaccurate. So the Terifit language is not the only example here. Like there are thousands of examples of these languages where the LLMs or like the NLP systems underperform, and these languages are called low resource languages. So basically they are like low resource because like maybe they have like less data, or maybe they have like less they have like less funding. Like there is like several reasons. And the very sad thing here is that these low resource languages are being spoken by a majority in the world, like around like 3 billion speakers. So when we don't have access to this kind of like 3 billion don't have access to like NLP solutions basically. So if we helped in order to make NLP systems like more accessible for these languages, then we are basically helping to bridge the cultural gap between societies across the world and making the technology like accessible for more and more people. So the good thing is that we all know that like there is recent work that people have already been doing to propose new methods that can make the existing LLMs adapted to some new languages. So let's say we just like take the work that I'm highlighting here, like from NVIDIA, where they made the Nemotron model like adapted to the Hindi language. The way they have done it was like very, very simple, but like it's a smart way. So they just like took English data, they translated it to Hindi, and then they pre-trained the model on this translated data, and then they got a model that can speak Hindi very fluently. This is good because like it works like in terms of like benchmarks and so on. The model like is able to speak Hindi, and it's able like to translate and do like all these linguistic based tasks. But one weakness of this kind of work is that when you train on translated data from English, then you are basically transporting the bias of the culture from the Western culture to the target culture. One example is that, let's say if we train a model for an Arabic LLM model on data translated from English to Arabic, then that model may exhibit some bias towards the Western culture, and that bias we can see it in the cultural concepts that the model is proposing. One example is like, let's say I want to make something for dinner, then LLM would suggest some Western dishes for dinner, like steak here, which is not aligning with what maybe an Arab person would made for dinner. And what we want to say from this slide is that if we have an LLM that is very fluent in the language, it doesn't mean that that LLM is competent in the local culture of that community. So in this slide, you just like see several concepts or like cultural concepts that we have in Morocco, like when it comes to food, to clothes, to architecture, to folklore, arts, music, uh, like these are like several cultural concepts. We took like this model that you see like on this slide that was like trained on machine translation data from English to Moroccan dialect, and it was like performing really well on the Moroccan dialect tasks. And we asked it a very simple question. Like this question is, how do I make shabakia? Shabakia is like a Moroccan sweet that all Moroccans basically know. So if I go to Morocco and I ask any person there like how to make this dish, the person like should know. And then the answer that we got from this LLM that is like Moroccan, trained on Moroccan dialect, is fully hallucinating when it comes to the ingredients. Even like when it comes to the type of the dish, like it says like bread while it's a sweet. Uh, the model is like giving us like this very wrong answer, meaning that like what we said in the previous slide is aligning with what we have here. And I know that like we cannot make assumptions based on one example. So what we have done is like we took a cultural benchmark that would help to evaluate how an LLM performed the Moroccan culture. And we found that this LLM here performs under 5 on 10, means that like it can't answer like half of the questions or more when it comes to Moroccan culture. So that's why we said, okay, instead of training the models only to learn the language, we need like maybe to add like the cultural dimension within our training. And then we propose a new method that can basically help get this data that is like both culturally and linguistically aligned to the local community. So the contributions that we had in this work was like first, like we just like proposed Nile Chat, which is like a 3 billion model to released open source, and that covers like two Arabic dialects, like the Moroccan and the Egyptian, considering both like their language, their cultural heritage, and then the cultural values. We proposed a novel framework that can help generating synthetic data for these three dimensions, like the language, the cultural heritage, and then the cultural values. And we release like these data sets like open source to researchers to be used. And then we also release like some new evaluation tools. So one question that maybe people would have here is that we are saying that we want to align an LLM towards like a specific community. Then how do we define the community, or like how do we represent a specific community? So in our work, we focused on three dimensions. Like the first dimension that we would use like to represent a local community is like the language. And when I say the language, I mean it's like the local dialect that the community have, the style of writing. Then the second dimension is like the cultural heritage. It means like all the food, the celebration, the art, the history, and so on that they have, and the cultural values. The cultural values means like the social, the political, the economic, the religious, and the ethical values, and then the norms that they have at that community. Each of these dimensions, we can craft just like a very customized like method to generate data for it. So let's say for the language, we have opted for the following. We said like, okay, let's take some pre-existing cultural agnostic text and then translate it to the local language. And when I say cultural agnostic means that this text like is not aligned or biased to any culture. The second dimension is the cultural heritage. For this, we will just like take, let's say Wikipedia, and Wikipedia have like these portals that would cover like the culture of each country. So let's say if I say Morocco, I would just like go to Wikipedia and then I would find like a portal that have like all the topics that are related like to Morocco. And then I would crawl all the concepts from there. And then we can do another step, which is like just like go to the web and query the web to try to find all the articles that are related like to these cultural concepts. And combining this data, I will have like some data to represent the cultural heritage. The third dimension is the cultural values. So for this one, we just like need to craft some local personas, descriptions that would mimic the values of the target community. So the requirements that we need basically to do like this data generation or like synthetic data generation are the following. And these are like the ingredients basically that we have used in this work. So first we need like the local context knowledge. Local context, it was like from Wikipedia basically. We just like go to the country level portal of that country and we get like all the concepts from there. And also we crowd like all the local news of that country. So it's a Morocco, we just like went and we found all the newspapers there. We crowd all of them to have like some local context knowledge. And then the third part is like the parsing the search engines using the concepts we got from Wikipedia. For the values, we got the description in the following way. The description of the personas in the following way. So we all know that like the World Value Survey was executed on maybe, I don't remember exactly how many countries, but for every country, like they asked people around, like the participants around like maybe 200 questions. So what we have done is that we took these questions and we parsed them in a text. And then we had like a very long text that would like take all this question and answer. And then we gave them to the LLM and we said, just like summarize it in a very concise personal description. And then we use that personal description as a description that would define a person from that community. And basically to do like this data generation, this synthetic data generation, we need a teacher LLM that can speak the language. That's like an assumption that we have in this work. We assume that like we have access to a teacher LLM that can speak the language. So here we use like Command R plus. At that time, it was like the best model that we could have used to generate the Moroccan and Egyptian dialects. So, okay, given these ingredients that I showed here, what we have done is that we did something that we call like control generation. So control generation means that we want the LLM to generate for us, let's say, some text genres, but we want to control the factuality of the information that the LLM is going to generate. We just like want to restrict what the model is going to say. So to do this, like we just like give it some context, and this context is coming from the data that we got like from this slide basically. So the context is like, let's say the cultural heritage concepts. I would give it like the concept, the title, and then the description or like the text. I would give it the persona. I would give it like some linguistic cues and expressions or like some idiomatic expressions. I would give it like the local news. And then I would craft the following prompt, like act like the following persona. And then here I would put the persona description, write, I would say like text genre is like a conversation in, let's say, Moroccan dialect, including the following expressions and cover this context. And then the context here, I can just like take any article that I crawled before and then I put it here in the context. By doing this, like I can just like have, let's say, these inputs, and by using them, the LLM, since it's able to generate the dialect, it can generate the dialect and generate a text genre that aligns with the culture, basically, by including the linguistic cues that we had here, by including like the local context, and then by adhering to the persona that we have included in the framework. So to do this, we just like built a very lightweight engine that helped us like to generate this data large scale, and we just like executed it on our servers. I mean, like most of this like was on Compute Canada, but we just like made this like large scale. Like we had like a lot of nodes, and then we just like served VLLM or like served this model quantized like in 8 bits on all these nodes, and then we had like a lot of responses like from a lot of combinations of prompts. By doing this, basically we generated like data for two communities, like the Moroccan and the Egyptian. For each of them, we generated around like 3 billion tokens or like 3 billion words. Part of that data was machine translation. Part of it was like using the controlled synthetic data generation. And we have done the same for these both languages. So now we have this data. The next step is that we used this data combined with pre-existing data to fine-tune or like to further pre-train Qwen 2.53 billion. Yeah, that was like the first step. And then the second step, since we want our model to be an instructed tuned model, then we have opted for a supervised tuning phase where we just like translated some English data using the teacher LLM to the corresponding dialects, and then we made one model for Moroccan and one model for Egyptian. And because we wanted like to have a one final model, we just like did some merging at the end using like linear average, and we got like our final model. So, okay, so if you remember well, like in early slides, in an earlier slide, I mentioned that in this work, we consider like three dimensions. Like the first dimension is like the language, the second dimension is the cultural heritage, and then the third dimension is the cultural values. So evaluation-wise, we need to evaluate like each of these dimensions. So for language, we have used like the linguistic understanding like tasks like EGMMLU, EG Swag, both like for Moroccan and Egyptian. And then we use like machine translation using like Flores, and then we have like an in-house data. For culture, we use like the Palm benchmark, which is like a benchmark that is like that covers like most of the Arab countries. And we took the Moroccan and Egyptian subsets from it. For the values, we have used like the world value survey to see how aligned are the responses of the model like to the world value survey. And then we took like a subset of the data at the end to see just like the quality of the generations that the model or like the teacher model was doing basically. Yeah, the results show that like our model, even if it's like a 3 billion model, it outperforms many like all the less than 7 billion models at that time. And also it outperforms many of the existing 7 billion model and more at that time, which is like a very good thing for us at the time. Like it was just like by doing synthetic data generation and training the model on it, like you can outperform like many of the super performant models at that time. Same for Hella Swag, we got like very good performance. Same for Bilibili, and then for the cultural knowledge, we can see that like our model is here like outperforming the baseline. With the baseline is Coin 2.5, and also outperforming like the existing models that were like built for these languages. Like Atlas Chat like 2 billion was like built for the Moroccan, and can see that like our model like is outperforming it. For machine translation, we had the same, like we can see the same pattern, like our model is performing better than the less than 7 billion, and also better than the more than 7 billion, except for the no language left behind. Here, like I guess the reason is that no language left behind was like a model that was fine-tuned only for the translation tasks. So like it makes sense that maybe like this model like would outperform us when it comes to translation. So we had like, and also it was trained, I guess, on Flores 200. So like maybe this model was like biased on this data, maybe. And we have done like we had like an in-house like machine translation data, and we evaluated our model, and we found that our model now like performs like better than all the baselines, including like the no language left behind. Values wise, we have compared the answers of our model with the original answers, and we found that when we fine-tuned on this data, like the model is now like way more aligned compared to the baseline, which is like the green line here, like except for some values dimensions. When I was making these slides, like last Friday, I guess, like I was just like checking some public leaderboard for Arabic LLM progress till now, and it was like good to see that like this model is still outperforming like all the existing models under 5 billion parameters, and it's doing like the best in terms of performance.
What
This
models are
model,
doing the best?
sorry, the our model.
But it says number 21. So
Yeah,
what's
yeah.
number
So
one?
this is like for
Yeah, so bigger model. So what is doing the best?
so bigger model. It will be like Gemini basically, if I remember
Yeah.
well. If I remember well. So
Uh,
yeah, I have like the another slide which shows
oh,
the
here.
ones
Yeah,
that
yeah,
like
yeah.
under 20 billion, and here we can see that our model is still outperforming models that are like 14 billion, 9 billion, 9 billion, and so on. Just like some insights about the training. Training the model was basically we had like around like 100 billion tokens, and we found that mostly the performance started like to be plateaued like around like maybe 60 billion tokens. Uh, yeah, so to conclude, like I feel that scientific data generation is a very good path, like when it comes to building LLMs that are like both culturally and linguistically aligned. Also when it comes to evaluation, I guess like the evaluation should be like on the cultural and the linguistic side, not only like the linguistic side. So we have released like this model, like open source on Hugging Face. We release like all the pre-trained data that we have generated. We release also like some new benchmarks that we created, like AGMMLU and AG They are both available like on Hugging Face and then on the Harness framework. Yeah, thank you for your attention. And yeah, please go ahead if you have any questions.
Yeah, okay, thank you so much, Dr. Abella. And I think that Professor Annie have a few questions on the during the
Yeah.
uh,
So I guess have you seen Cohere's data? Have you seen Cohere's data augmentation paper? Um, I think
When was it released?
I think we were ch when I checked to Julia, they were talking about it back last November. But I guess I don't know what ha I haven't been tracking it.
Yeah,
Um,
I'm trying to
it,
remember like which paper was that.
that's okay. I think I haven't been tracking this paper. It was just on GitHub. I mean, sorry, it was just on archive, but it wasn't accepted yet. So I think I think what end up happening is they're probably trying to. Oh yeah, so I don't see it anymore. So I don't know where it is. But I think maybe they're trying to figure out where they can publish that paper. Yeah, and I guess my other question is, did you like how much compute and runtime did it take to build your small model and how many and compared to sort of, and then do you have a runtime comparison?
Like runtime comparison to what exactly?
Runtime comparison to maybe like some of the, I guess you don't have that runtime comparison, but at least like some internal runtime
Yeah,
comparisons
yeah,
for your model
yeah.
versus a bigger model, and then how long it
Oh,
takes to train. Things
yeah,
like that. Sorry.
I guess like it depends on the number of tokens basically. Like it's like if you know like the number of parameters of your model and you know like how many tokens you are going to train for, so you can estimate how much time your own hardware can do like in order to fine tune that model on that data. And also it depends on whether like you are opting for full parameter fine tuning or like for LoRa training.
Yeah.
So in this
What
work we have done like full parameter tuning, and we have tuned this model on 4 GPUs, 880 gigabytes, a 80 gigabytes each, and it took us like maybe around like 2 months of training.
uh
To,
okay. Oh, sorry. What kind
yeah,
of models?
it was like a 3 billion model.
Oh, sorry, sorry.
2025.
Sorry. What kind of servers? What
Oh
kind of
yeah, just
servers?
like A100, 80 gigabytes, like four GPUs.
For 2 months?
Yeah, for around 2 months. Yeah.
I guess you did it at MZUB.
No,
M
it's just like to here.
Yeah,
Yeah,
yeah.
and
Because
then
I don't think UBC has the compute.
I guess like it depends on the lab, honestly. Just like if yeah, it's like lab dependent. Like some labs they do, some labs they don't. So a
Okay.
lot of things. And also the for the scientific data generation, it took a lot of time. Like it took way more than the training itself because like you have to make
Uh-huh.
a VLLM engine basically running 24 on 24, like taking the prompts and then generating for you the text. So for this, like we relied like on Compute Canada mostly, and because like you can just like parallelize your scripts there. So we just like submitted like a lot of jobs, and then we balanced like the requests like across these jobs, and then just like we
Yeah,
prayed that we get
yeah.
like the jobs like
Yeah, so
allocated.
you can only build this model because you have a lot of compute. I
And
don't
this
think we
model
can.
was basically like was that was like the main experiment that we wanted to do. Like the main experiment was like if we can get like a lot of synthetic data, then we can opt for this and then get a very performant model. So the good thing
Yeah.
is that this model here, like IBM, it was like from IBM research in
Uh-huh.
UAE. It was released last week or like the
Oh.
last 2 weeks, and then they followed exactly like the
Mm.
the same approach that we have done. Just like they took the same data, they
Yeah.
translated it like using an open source model, and then
Yeah.
so the for us like the main findings here was is like let's say like we have some grounded knowledge, can we use an LLM to generate or like augment data for that specific community based on this cultural knowledge?
Right. Right. Okay.
Okay. Yeah, thank you so much for the presentation. Also, I have one more question.
Yeah, okay.
Like you mentioned about like I think this synthetic cultural data augmentation, and that was really inspiring. And when you mentioned that you incorporating the cultural heritage by parsing cultural level Wikipedia pages, were you mainly using the English Wikipedia pages or the Arabic or local language versions or both? Because I think if you use English, it will be biased. Also, do you think relying on Wikipedia sources can introduce certain biases? For example, like it's more formally documented and globally visible aspects of culture and yeah, things like that.
Yeah, good question. So yeah, I feel like that, at the end, whatever data we put in the model or like we put in the training data can be biased like to sort towards like some entity somehow. We just like trust Wikipedia like to some level or like to some extent. We trust that maybe the knowledge in Wikipedia is correct. To answer your question about like the language, like here in this work, we have used like the Arabic language Wikipedia. So the experiment, or like just like some quick stats that we have done is like we crawled like all the Wikipedia. We saw how many articles we can find like about Morocco there, and we have done the same for both like the Arabic and the English version. We found that for Morocco, for example, in Wikipedia, we have around like 50K articles speaking about like cultural concepts in Morocco. Like for the Arabic version, for the English version, if I remember well, it was like around like 25K or something. So it's like half the number of articles, which makes like a lot of sense. Like most of the articles are like Arabic first based, and then like maybe people can make some translations to them like later if they want. But like I guess like going for the local language, if Wikipedia supports that, like is a good thing. Otherwise, like you can all the time like crawl both versions and then use them at the same time. Because like these prompts are like basically language agnostic. So if I put the Arabic article here, or if I put the English one, like both of them, like it wouldn't like hurt that much. Especially that if I believe that if we do exactly the experiment that I explained here in this work, if we do it today with a better teacher model, we will get like much better performance.
Oh yeah. Oh yeah, I think I see. Yeah, so yeah, I was thinking about the same thing because when I was looking at the Chinese, like I'm Chinese, so when I look at the Chinese Wikipedia, like the Chinese version of it, it's like way more comprehensive compared to the English original, like English version of it. So yeah, I do think it is like really important to have this kind of insights. Yeah. Does anyone else have any other questions? Okay.
Okay. All right. Yeah. So, Qifeng, if you can summarize like the questions, and then I guess Hajra will send a thank you email to Dr. Al-Maki.
Yeah.
But this is very interesting work because we're also doing some. I mean, I specialize in Hokkien because it's my mother tongue and native language. But we're also building a language model. But
Oh, perfect.
uh,
Yeah. You mentioned something about compute. I guess like this slide would be something very important, like that, you can get basically like most of the boost that you get in terms of performance, like it's getting from the first 10 to 20 billion. So
yeah,
you don't need to go like for like
yeah,
large scale in terms of
yeah. And because I think it's a little bit of a different issue. Hold on. Uh, I guess for Hokkien is because it's a dialect. Oh, Santiago has a question. It's a dialect, just like Arabic has a lot of many dialects, right? There
exactly.
is a lot of confusion and code mixing. Um, so I think there isn't even a great evaluation benchmark to sort of differentiate that very
Mhm.
carefully. So, yes, this is one of the insights we did for, we also had a similar insight for data scaling, but we didn't build a model. We just we did a small problem for transformer. We observed the same thing for transformers, but this is obviously
Yeah.
you built like a much larger model. Um, yeah, so this is interesting. Thank you.
Yeah. Thanks you.
Yeah. Thank you. Santiago, you can go ahead.
Thank you. I was no, I guess my question is very short, but I was very curious about if you measured the quality of the translation,
Yeah.
uh, like because I feel like sometimes like as times goes on, I think like it's way easier if you have collected the data, right, and then you translate it again with a better like translation model. I was wondering first if you measure it, and second, how much effort would it take to maybe translate it again, like with the tools that are currently available,
Yeah.
and would you think that would affect positively your results, and how much?
Yeah. So yeah, that's a good question. So I feel like, data filtering is a very important step here, like especially when you generate like data large scale, because here we are just like running the model and then praying that maybe it will give us like it will just like follow the prompt basically. And here, like all this like depends on the teacher model that we have. So here it was like command R, for example. The issue that we had with command R at that time, it was when you ask it like to generate or like to translate to Moroccan dialect, for example, like the model would start like to generate like some repetitions of the engrams, and basically like the model starts like to hallucinate after some moment, like you will find like a big portion of the text is like being repeated. So we built like a script that would just like scan the generated text for these generations, and then we removed them for these repetitions. I mean, we found that like out of all the data that we generated, like 2% of the data was like, having like this kind of repetitions. So this was like taken out. Now to go back to your question about like the translation quality, we took like a random 100 sample from the data, like 100 or 1000, I don't remember. We have like this stats on the paper basically. So we have like took I don't remember exactly what's the number, but like let's say 100. We took like 100 random sample from the data, that have like the English and then the dialect translation. And we have done a human evaluation on it to see whether the model is adhering like two metrics here. Like the first metric was it was whether the model is generating the data in the correct dialect. And then the second metric was whether the model is generating an answer that is semantically correct to what we want. So when it comes to the semantics, we found, and then we scored this like on five basically. So the human annotator, we asked them to do like on five, like from 0 to 5. So for the translation quality, or like for whether like the model was following the dialect, it was like around like 4 on 5. That's what the human annotators like told us. And for the semantic, or like for following the instruction, it was around like 4.5, or like four, I don't know, 4.5 to 5, but like it was a high score for both of these two metrics. We have done this like using with two human annotators, or like human participants that have done this evaluation, and by comparing like the agreement between them, we found that like, it was like a high agreement. So we trust that this model at that time, it was like a good model to do this generation. Yeah, you asked also like about whether like if we repeat the same experiment with a better model, or like that exists now, whether we will get like better results. Like first, this experiment is like, a lot, like very expensive. So at that time, the model that we use, it was like 100 billion parameters. Right now, there exist like many models, like let's say Gemma, is it like 21 billion or like 27? So there is like this Gemma model that is like very like much smaller in terms of size than this model, and it performs much better when it comes like to translation and in following instructions. So if we use the same model, we can just like basically get higher quality of data and use less compute, like way less compute. Yeah, I hope this answered your question, Santiago.
Yes, thank you very much.
Yeah. Um, yeah, thank you again, Dr. Abdallah, for your work and sharing your work with us today. And we really appreciate the time and the insights you give us. And also thank you everyone for joining and participating, asking questions. So yeah, we hope you have a good rest of the day, and thank you so much for presenting it.
Yeah, thank you. It's my pleasure. Thank you. Thank you,
Yeah,
everyone.
thank you everyone.
Thank you. Bye.
Bye.
Bye bye.